Hello, this is a problem about a flow state. A gas is flowing through this tube and some properties are supplied, and we are supposed to find some of the unknown state properties. So let's call this flow state state 1. So we'll start by listing out what is known and then evaluating properties such as specific volume and rate of transport of Ke, etc. So what we know about state 1, oops. The mass flow rate is supplied 83.63. kg per minute, and if we transfer that into kg per second, it turns out to be approximately 1.4 kg per second. Okay. Area is given to us 0.1 meter square. Velocity is given 20 meter per second. So let's solve the first part. The question is find the specific volume. We know that m dot, the mass flow rate, is given as density times area times velocity, and density is 1 over specific volume. So therefore, to find specific volume, all the information we need are given. Area is 0.1 meter square, velocity is 20, and the mass flow rate is 1.4, and that produces 1.43 meter cube per kg. The rate of transport of Ke, which is called Ke dot, is the rate at which kinetic energy is transported by the flow, and is given by mass flow rate into specific kinetic energy. Recall that the transport equation is what? B dot equals B times m dot, where B is the specific property. So how much kinetic energy is carried by this flow? We already have evaluated m dot, and Ke is what? V square over 2 times 1000. So then it will be in the unit of mass flow rate is kg per second, and you can show that this is kilojoule per kg, so it will become kilowatt. Substituting the numbers, m dot we got is approximately 1.4, 20 squared by 2000, and that should be about 0.28 kilowatt. And finally, the flow work. Recall what is flow work. As the flow is going through, essentially it's pushing the flow from left side to right side of state 1, and that's the flow work, which is the formula for that is the force, which is pressure times area times the velocity. Remember, force times distance is work, force times velocity is rate of work. So again, all the properties are supplied. Pressure is supplied, area is supplied, velocity is supplied, and the answer is simply 200 kilowatt. So notice that when the flow moves through this cross section, it is not only the kinetic energy it's carrying different types of energy. So it carries Ke dot, which is m dot times Ke. It carries Pe dot, which is m dot times Pe. It carries, in other words, it carries E dot, which is m dot times E, which includes Ke, Pe, and U. And finally, if we add with E dot the flow work that it carries, that's called J dot, which is m dot times J. When there is a flow, it carries, this is called the flow energy. The total energy that it carries is given by J dot, and we'll learn more about that in the coming chapters. And that will be very important in understanding the energy equation that we build for a generic open system.